Okay, we're going to carry on with our next session now. This is Ingo Uckelmann. He is Head of Academy and Alliance at the Fraunhofer IAPT. We're going to be continuing the theme of the additive mobile factory. Ingo now will demonstrate how we can use this for on-site component repair, reducing downtime and enhancing operational efficiencies. So, Ingo, over to you.
Yeah, thanks a lot for the opportunity to present here today. And with reference to you, I have a rather similar presentation. The title is AM in the Box, Repair of Components on-site. So, first of all, I would like to present briefly the Fraunhofer IAPT. Some slides about that one. Then we will go a little bit into depth about the mobile additive manufacturing. And afterwards, I will touch briefly on an outlook. About the Fraunhofer IAPT, I wrote the whole official title from our website. I put here in the first line. And as you can see here, additive production. So we are really the only Fraunhofer institute with a specific task in the additive manufacturing. So this fair here is our home turf, the must-go fair. We are located in Hamburg, Bergedorf in northern Germany. So usually it's only, I would say, 4-hour drive. But if the train runs as it runs, it's sometimes 7 hours. So that's dramatically bad. We have been founded back in 2009 as Laser Center North and then transferred to Fraunhofer in 2018. So we are rather new institute in the 80 institutes of Fraunhofer. We have roughly 100 employees and roughly 10 million turnover in our institute. Probably as you can see here, Laser Center North implies, I mean, we started with a laser and it had been kind of like our heritage to work with lasers and with metal. So no surprise in this graph to show what is our core technologies that we have here. You can see here, of the 4, 3 are metal. DED, powder bed, and sinter AM. And for sure metal extrusion. And also, and that's, I would not say rather new, but we are engaging here more and more, is SLS for plastics and material extrusion for plastics. As an offer to our customers, we guide them through the whole development of new processes, new materials, new machines. I will not go into depth here in all the details. I want to highlight here the training and consulting. So if you have any questions, any task where you think you might need help, please reach out to us and we will try to solve whatever task you have as soon as possible. Here you have a pretty detailed view on all the process steps that we can cover in our production. And in our institute, I will not go into details here, but be assured we don't really look in all the details of the process chain, but we have a more holistic view on the additive manufacturing processes in the sense that we start with a request of our customers until the task is solved and try to automate along the process chain and industrialize additive manufacturing. We have split our areas into 4. And you see them here: energy, life science, mobility, and security. And probably to highlight 2, 3, here in the energy field, we are active in the market of hydrogen, additive manufacturing for hydrogen applications. That's a big field we're working in. Then we have here life sciences. There we are talking about implants, so that's where I'm coming from originally. Then we have mobility, definitely, railways, cars, all kinds of stuff that's moving us. And today we are in the security, other ones would say defense area. And there we have the on-site and on-demand spare parts business in our portfolio. Now, going to the mobile additive manufacturing, and that's very similar to what you have presented before. Yeah? If you are in the need of a spare part, wherever it is, whenever it is, usually what is state of the art today is that you have a central warehouse somewhere, and if it breaks, the warehouse, we put it here somewhere in Europe, doesn't matter. But if something breaks in Indonesia, you might be waiting for a few days, and if you cannot apply it immediately, bad things can happen. And we all remember the drama with the Evergreen in the Suez Channel. I don't remember anymore. It was probably a week that nothing went back and forth anymore in the Suez Channel, or, for example, the Corona pandemic. So those are incidents that we haven't thought of ourselves. That's real life, what happened. And there it might make sense to have a more decentralized production. And there we are. And if we take into account the ship, it's kind of like natural to think right away about a shipment container, to have those shipment containers where you really need potentially the spare parts and be as flexible as you can be. And for that, additive manufacturing is perfect. You have this kind of like central warehouse with all your data here, and then you can send it anywhere, wherever your ship or your application is. Now it works. To give you a little overview about the systems that we know of are in the market right now, we have on the one hand definitely Hensoldt, then we have seen it, field made. So then we have AddUp, for example, we have Millbot, and we have bionic production. So bionic production doesn't exist anymore, but the technology still persists. It's in usage. And as much as I know, several of those containers are in use, status today, and do their jobs. What you can see here, different technologies, laser powder bed fusion, SLA, FFF, WAM, and so on. So those are all kinds of different technologies. And we asked ourselves, what makes sense to put it in a container and ship it? And here we have a quantitative evaluation to see what makes sense. And I personally, I tend to go with the safety requirements here. So in this line here, the wire arc process is very easy to handle, no high safety requirements for powder, for example. With powder, potentially you have issues with burning, with inhaling, and so on. So wire arc manufacturing makes definitely sense to make it a mobile application and ship it worldwide. And it's easy to train also. Just an info why makes wire arc also sense. That's on the one hand the build rate and the track width that the technology has, in the sense of what is the detail I can produce with that system. And as you can see here, of all the technologies that we looked at, it's a good compromise of both. Now, applications. That's in the end what we are here for. Theory and is fine, but we want to see parts. And here on we are showing the detail level. So the smallest one is roughly, you see it here, 4 millimeters. Yeah, so that's it's not microscopic, definitely not, but it gives an impression of the minimum build size that we can print up to, and that's here by the company MX3D. And as much as I know, this is a part of a bridge. I think they put it in Amsterdam, and that is several meters. So that's the range of size that you can print with the wire arc manufacturing. Yeah, we leave this here. So how is it realized in our mobile factory? We have, as you can imagine, we have a robot here. We have the warm torch at the end, and then the part and positioner. And for sure, we can add here multiple robots, for example, for milling, also for part handling. So that, as you know, robot is widely known in all kinds of production processes, and that gives us the opportunity to scale here the process and really be super flexible regarding the parts and part size for sure. This is the mobile factory that we have. So I don't know if you've seen it in our premises. We have here the robot. We have here where the additive manufacturing, the printing, the wire arc process takes place. And here we have a milling station, which means you can go directly from the printing to the milling, and ideally you have afterwards a part that you can mount directly in whatever application you have there. As much as for that specific application that we developed here, it's fully automated. We can train the people and really bring here the production of parts, mostly it's spare parts, into life. Just some details here. The weight is roughly 4 tons, so I think it can be handled by most of how you say ships and containers and so on. Welding source is a Formnext TPSE, and we have a milling machine in here with up to 48,000 rounds per minute. We ship it around. It's not a theoretical thing that only happens in our premises. No, we, as you can imagine, we wanted to have it outside in the wild. We did that, not here, not today. Be invited to us in Hamburg to take a look at there. And in some specific fairs, we even bring it out. And there we also demonstrate really on-site, online, how the printing and milling afterwards can work. Unfortunately in the sense for me personally, but we started with a ship to be an application, but nowadays main demand is in military applications, defense applications, and it's not only printing of parts in the sense of new parts, but also in the sense of repair. And we see it here with the Belgian army. We had a project running where we have this carton joint repaired by the additive mobile factory. Here you see how it's mounted on the robot arm. Here the original part. Here we prepared the part for the printing. And then, as you can see here, we printed it on. And it was only roughly 1.5 hours. And that might be the difference between successful employment of military equipment or not. If you have to wait a week or whatever until you have the logistics, that's the difference. Similar example, but then with the German army, we have here a part of a door locking mechanism. Again, here prepared. Then we welded on it and mounted it in the door perfect. I don't know if that's really true. 2 minutes, I doubt that with all the preparation. But let's say less than 2 hours, fully mounted. And that's exactly what, unfortunately, what we need these days in the defense sector. Third example is the French army. Yeah, sorry for all the army examples here, but we have here an example of a minesweeper. And here we have a rotating instrument to find and let explode the mines. And as you can imagine, those claws, you see it here, those claws are mounted here at the end. Yeah, they tend to be destroyed. So perfect with the mobile factory, we can print it within 2 minutes and up and go we are. Another example is, unfortunately, we have sometimes floods in Germany. Yeah, so we printed here a spare part for the tubes, yeah, for the pumps, and that we built within 4.5 hours as an application. And afterwards, we were able, or the THV was able to, yeah, let the pumps running again. So this is a little bit different case in the sense that the lead time of a forging part was 3 to 4 months, and we could do it within 2 months. So it's not originally the use case that we're presenting here, but it's also a kind of use case where we can reduce significantly the lead time. Yeah. Don't get me wrong, but this is not a replacement for standard spare parts. So if you have the spare part, the original spare part, please take the original spare part. Yeah, this is a substitution. Yeah, if you don't have it, we can go for additive manufacturing. Yeah. Which brings me to the outlook. Yeah, we have the additive mobile factory. We are always looking for partners to further develop the container to see how it works in principle. As Fraunhofer, we don't employ them. Yeah, we are not in the field. Yeah, we are not assisting in the field. Yeah, that's what we're not doing. We are developing the concepts. We are developing the container. We help you to make your ideas come true. In that sense, yeah, we have a process manager where we can do all the IT stuff in. And with that, I see 2.5 minutes, perfect. I want to thank you. Yeah, so the main authors, Robert Lau, Olaf Steinmeier, my colleagues, they couldn't make it here today, so I'm their deputy right now. I'm not into every detail of the mobile factory, but if there are questions, I will be glad to try to answer them. So, thank you.
Thank you very much, Ingo. In terms of partners, development partners, what specifically are you looking for there?
All kinds. Yeah, we're very open. Yeah, as I presented, is it mobility? Is it life sciences? Is it security, defense? And then, I mean, that's the markets. Is it a machine building company? Is it a software company? Is it an end user? Yeah, like the military applications here. It's wide open. Yeah, we are your partner to assist you in whatever question you have, what task you have, and we try to solve it as soon as possible.
Perfect. And if you don't have any questions here, but you think of anything, you can, of course, go down to the Fraunhofer stand where you can learn about this and from all the other Fraunhofer divisions and the amazing work that they're doing across additive manufacturing. So, Ingo, thank you very much.
Thank you.